So here's a few simple probability examples to continue. And first one is if you draw a single card from a deck of 52 playing cards, what's the probability of first drawing a club? Well, the probability of a club will just be the number of favorable outcomes, which is going to be 13, because there are 13 cards in the suit, over 52, which reduces to 1/4. Now, what's the probability of drawing a club and an ace? Well, this is, you can draw a club and an ace. So the probability of drawing a club and an ace will just be the probability of drawing an ace or a club times probability of drawing an ace, which is 1/4 times 1/13, which is really, I'll show you how I got that number. There are 4 aces out of the 52 cards, so that's 1/4 times 1/13, which is 1/52. So if you consider this question, what's the probability of drawing a club and an ace? Well, there's only one card that fits that in the deck of cards, and that's the ace of clubs. So your probability is 1/52 of drawing that card. So next, what's the probability of drawing a club or an ace? And so now we have to ask, is that mutually exclusive or non-mutually exclusive? And you can draw a club and an ace, and that's the ace of clubs. So the probability of club or an ace will be equal to the probability of drawing a club plus the probability of drawing an ace minus the probability of a club and an ace. So as we said before, probability of drawing a club is 13/52. Probability of drawing an ace is 4/52. Minus the probability of drawing a club and an ace is 1/52. So that's going to be then 16/52, which reduces to 4/13. And so that's approximately equal to 30.7, or I'll say 30.8%. Now, a company that manufactures flashlights knows that 3% of its daily production results in products with a defective bulb. 5%, so I'll just write this, probability that it's defective is 5/100. Sorry, is 3/100. And 5% have defective batteries, so and 2% have both. Or 2/100. And if flashlight is selected at random, what is the probability that the flashlight will have a defective bulb or a defective battery? And so now this is non-mutually exclusive because we're told up here that we can have both a defective bulb and a defective battery. And so therefore we know both events can occur, so this is non-mutually exclusive. So the probability of defective bulb or a defective battery will be equal to the probability of a defective bulb and plus the probability of a defective battery, which is 5 over 100, minus the probability of both defective and the bulb and the battery are both defective. And so this is going to be then 6 out of 100 or 6%. The probability that a young Canadian plays soccer in the summer is 0.57. The probability that a young Canadian plays hockey in the winter is 0.83, assuming that these are the independent events. If a young Canadian is chosen at random, what is the probability that they play hockey or soccer? So this part of the question is asking whether the or, again, ask yourself if that's part of it, trying to figure out the probability of an or statement. Then ask yourself if it's mutually exclusive or non-mutually exclusive. And since you can play both hockey and soccer, that means that it is non-mutually exclusive in this case. So the probability that they play soccer or hockey is equal to the probability that they play soccer plus the probability that they play hockey minus the probability that they play both. Actually, I'll write that as so the probability that they play both soccer and hockey. Now, the key thing here is because we're not given this, and we can calculate this because remember that the probability of two independent events, so the probability of the Canadian playing soccer and hockey, since we're dealing with independent events, will just be the probability that they play soccer times the probability that they play hockey, which is going to be 0.57 times 0.83. So the probability that they play, and then we're going to use this up here. So the probability that they play soccer or hockey is the probability that they play soccer, which is 0.57, plus probability that they play hockey, 0.83, minus the probability that they play both, which is going to be 0.57 times 0.83, which is equal to so approximately 93%, 92.7%.